Welcome to the bada video lecture. In this lecture, I'll explain a few advanced UI concepts. I'll cover topics such as how to construct some sophisticated UIs using other UI components. I'll discuss items such as orientation, the search bar, gallery, advanced lists, multiple forms, multi-point touch, animations, layouts, and also how to design a UI using the UI Builder. Now, we're going to learn about the common properties of advanced UI controls. From these, I'll show you an application that uses containers and multiple forms. Then, I'll explain how to create a UI using the Interface Designer. First, let's look in detail at the orientation feature. The orientation feature allows the application to register and listen for orientation changes. The orientation changes by rotating or holding the device in a different direction. bada supports the landscape, portrait, landscape reverse, and portrait reverse orientations. Now, let's have a look at the functionality of the form that's used to change the orientation of the UI when the orientation of the mobile phone is changed. First, to make the form react to a change in the orientation of the terminal, you have to set the form as a subclass of the iOrientation event listener. Then, you need to register this object in the construct function of the form by using the orientation event listener of the form. After registering this to the listener, if the orientation of the phone is changed, the onOrientationChanged function of the listener object is called. At this time, the current orientation of the phone is provided as an input parameter. Also, the orientation of the UI can be changed by changing the location and size of the subcontrol according to the orientation of the phone. And finally, the draw method needs to be called to refresh the display. Next, let's have a look at the search bar and gallery controls. The search bar can be used to enter search keywords and display the search results. This control consists of a text field for entering keywords and optional left and right buttons that are displayed when the search bar enters input mode. The gallery is used to display a set of still images one at a time. You can scroll through the images horizontally. You can also display the images as a slideshow, which scrolls through them automatically. The search bar supports two modes: search_bar_mode_normal and search_bar_mode_input. Search bar mode normal is the initial mode, where the search bar looks like a single-line text editor. The search bar enters search bar mode input mode when the user taps on the text field. The overlay keypad and a content area appear underneath the search bar. In the content area, the UI control set with the setContent method is displayed. The search bar provides the iSearchBar event listener interface, which has the onSearchBarModeChanged event handler to report any mode changes. You can add the listener using the addSearchBarEventListener method. By default, the input mode search bar contains the Cancel button, which closes the keypad and returns the search bar to normal mode. To add another button to the search bar, you can use the setButton method. To handle button events, use the onActionPerformed event handler of the OSP UI iActionEventListener interface. You can add the listener to the search bar using the addActionEventListener method. In order to use a search bar in a form, we need to derive the class from the iSearchBarEventListener, which notifies search bar events through the onSearchBarModeChanged event handler. The iTextEventHandler listens to and handles events that are generated when the text in the keypad changes through the onTextValueChanged and on-text value change canceled interfaces. Here I've used list view for the content in the content area, and hence I've added the iList view item event listener and iList view item provider items. The two variables, _p search bar and _p list, are the objects of the search bar and list view items respectively. Now, let's look at the initialization of the form. First, I've constructed the search bar with a specified rectangle. The method setText will set the text on the search bar where there's no text in normal mode. Then, I added the Add Search Bar Event Listener and Add Text Event Listener items to listen to the events as I explained in the previous slide. Also, I used list view here as content control. So, I've initialized the list view and set it as content using the setContent method. The list view will be displayed below the editable area of the search bar. Here I've displayed the events interface. The event onSearchBarModeChanged notifies that the mode of the search bar is changed. The argument searchBarMode specifies if the mode is input or normal mode. The onTextValueChanged event notifies that some text has changed. The gallery is a UI control used to display a set of still images one at a time. Images can be scrolled through horizontally. Using the gallery, images can be displayed as a slideshow, which scrolls through them automatically using the Start Slideshow and Stop Slideshow items. It supports the provider class for adding or deleting images from the gallery or to retrieve a count of the images in the gallery using the getItemCount method. If changes are made to the images, use the Refresh Gallery or Update Gallery method to refresh a single gallery image or the entire gallery respectively. Using the gallery, images can be zoomed in or zoomed out of. The iGallery Item Provider item defines the methods for the gallery item provider. The application that needs to use the gallery must implement the iGallery Item Provider item and register the provider instance by using the setItemProvider method of the gallery. It provides the create item and delete item callback functions for the creation and deletion of the items respectively. iGallery Event Listener is the listener interface for receiving the events generated by the gallery. The application that needs to process the gallery-related events must implement this interface and register an instance of the listener using the addGallery Event Listener method of the gallery. The onGallery Current Item Changed event notifies the application that the current item has changed. The onGallery Item Clicked event notifies the application that the item is clicked. The onGallery Slideshow Started event notifies the application that the slideshow has started. The onGallery Slideshow Stopped notifies the application that the slideshow has stopped. Now, we'll look into some advanced features of the UI lists. We've already learned about the list view in the basic lecture. Here, we'll have a look at the custom item of the list view. The custom item allows custom drawings with the iCustom element. Also, the custom item can have elements such as text, image, and enriched text. To use a custom item, we first need to derive a class from the iCustom element and override the onDraw method. In the createItem callback function, the custom list element has to be added to the custom item object and returned, similar to what we've seen in the basic lecture. This code snippet above demonstrates the same. The custom list element class is derived from iCustomElement, and the onDraw method is overridden. Then, in the createItem callback function, the _p custom list element, which is an object of the custom list element class, is added as an element to the custom item and returned. List view supports a context item, which is visible on swiping the list item. A context item can support text as well as bitmaps. The context item has to be added to an individual custom item. Now, let's look at the listeners and user interactions. iList View Item Event Listener provides events for item state changes, i.e., when any item or element is clicked. An item sweep event notifies that the item has been swept and allows you to know in which direction the sweep was done. Then, if there's an event in the context item, the onListView context item state changed method is called. Now, let's look at an example. Here I've shown the class declaration. It's derived from the iList View Item Event Listener and iList View Item Provider Items. The iList View Item Event Listener interface provides the callbacks related to events, such as an item that's swept or there's a change in the context item state due to a user interaction. The iList View Item Provider interface provides item creation and deletion related events. Let's take a look at another example. Here, I've shown the initialization of list view. First, the custom list element object is created, and then we initialize the list view. The list view is constructed with specified rectangle coordinates. The setItemProvider method registers the item provider interface, and the addListView Item Event Listener registers the item provider interface to receive callbacks. Finally, we add the list view to the parent container using addControl. Here I've shown the implementation of a custom element which handles the custom drawing. The class is derived from iCustomElement, which provides the onDraw interface for custom drawings. This callback will be called each time the bada framework needs to draw the item. Overriding the onDraw method provides all the controls needed to do a custom drawing. The canvas of the item is passed as an argument. In the example above, the foreground color is green, and a text is drawn within the rectangle, which is passed as an argument to the onDraw callback. Next, I've shown the implementation for creating the custom item. The callback createItem is called whenever the framework needs to create a new item which is visible. First, the custom item is constructed with the specified rectangle coordinates and the normal style. To add elements to the custom item, the addElement method is used. As shown here, the custom element is added with the specified rectangle. The variable _p custom list element added here is an object of the class derived from iCustomElement. Next, we set the context item to the custom item. The context item is initialized, and I've added two string elements, test1 and test2, using the addElement method. The context item is set using the setContextItem method. As mentioned earlier, the context item is not visible by default. It only becomes visible after swiping on the list item. The event listeners I've shown here listen to different events in the list view. The item state change listener notifies the source, the index of the item, the element ID, and the status. The item sweep event notifies about the source list view, the item index, and the sweep direction. The context item state change event gives notification of the source list view, the item index, the element ID, and the context item status. In your application, there might be many forms, and you may want to manage them as well. Let's discuss that scenario now. Let's take a look at an application that uses more than one form. As I mentioned before, a form can be regarded as a page that constructs a single screen at a time. Therefore, in many cases, an application needs more than one form. When an application contains many forms, a process to switch between forms is required. I'll explain how to switch between forms using a simple example. As you can see in this example, I've declared two form classes. The application class has two form pointers. To switch forms more easily, I've declared the moveToForm function. This is the on-app initializing function of the application. While the source code created by the template creates one form, in this function, I've created two forms. After that, I've added each of the forms to the frame and set the current form as one of the two forms. This moveToForm function changes the currently displayed form based on the input parameter and form number. Here, I've checked the index range for safety, and if the index is within the range, the frame is acquired from the application. The required form is then assigned as the frame's current form. Then, the draw and show function of the frame is called to reflect the change. In this example, assume that a button has been attached to the form to enable the switching of forms. Then, if the button is pressed, the onActionEventListener function is called. At this time, you can acquire an instance of the application by calling the getInstance function and switch forms by calling the moveToForm function, specifying the next form. However, if you use this method, there can be a memory management problem. So, if you have to use multiple forms, it's recommended that you create a form manager. For more information about creating a form manager, refer to the basic app of the bada application sample. Now, let's look at a more interesting feature of smartphones, i.e. multi-touch. Using multi-touch, we can detect touches at multiple points at the same time. This feature provides notification events specifying the type of touch and the coordinates of all the points being touched. To use multi-touch, we first need to enable multi-touch as shown, i.e., using the method setMultiPointEnabled and adding the touch event listener using the addTouchEventListener method. Once a user touches a point, the event onTouchPressed is received by the application. In this callback, the information related to the number of points and coordinates are passed. As shown, to get the number of points being touched, first, the getTouchInfoListEn method is called to get the iList, which contains the information on touched points. Then, the getCount method of the iList is used to get the number of points being touched. Here we can see how the touch coordinates are extracted from the TouchInfoList. TouchInfo is the class that represents the points being touched. As shown, the getAt0 method will return the first point, and the getAt1 method will return the second point being touched. Let's have a look at the animation namespace now. An animation is an illusion generated by showing sequential images in a swift manner. It involves associating several key frames that contain values such as the position and alpha and the duration in milliseconds with a target object to be animated. The frames between the key frames are interpolated frames, which display a position calculated based on an interpolator. A simple animation only requires two key frames, the start frame and the end frame. A basic animation consists of a start value, a key value, which is automatically calculated using interpolators, and an end value. An interpolator defines the rate at which an animation changes in the given environment. Interpolators can cause various acceleration effects in an animation. The types of interpolators supported by bada are linear, discrete, ease in, ease out, and Bezier. The bada platform provides animation classes that provide methods to create an animation between the start and end values for the same data type, such as OSP base integer, OSP base float, OSP graphics point, OSP graphics dimension, or OSP graphics rectangle in a given duration using a chosen interpolator. The animation can animate two primitives, or it can be applied to a property of a UI control. bada supports integer animation, float animation, point animation, dimension animation, rectangle animation, and rotate animation. The animation group class can be used to combine multiple animations into a single one. An animation can be applied to UI control properties, such as the position, size, alpha, and rotation. The listeners available for applications to register and receive animation events are iControl Animator Event Listener and iControl Animator Detailed Event Listener. iControl Animator Event Listener is the listener interface for receiving control animator events. The class that processes a control animator event should implement this interface, and the instance created with that class is registered with a UI control using the animator's addControl Animator Event Listener method. When the control animator event occurs, a method of that instance is invoked. Similarly, iControl Animator Detailed Event Listener is the listener interface for receiving detailed control animator events, and it can be registered using the Add Detailed Control Animator Event Listener method. Common callbacks are onControl Animation Finished, onControl Animation Started, and onControl Animation Stopped. And the iControl Animator Detailed Event Listener has an extra callback, onControl Animation Repeated. Control Animator is an important class that's used to control the animations operating in UI controls. A control can be animated either by using predefined platform animations, by creating and setting the animation instance to a control using the Control Animator Set Animation method, and specifying the animation underscore target parameter value, or by defining an animation and starting it directly through the Control Animator Start User Animation method. All the animation methods are available in the Animations Control Animator class and can be retrieved by using the Control Get Control Animator method. In order to animate multiple controls simultaneously in an application, the Animation Transaction class should be used along with the Control Animator class. Let's take a simple example to animate a button from one position to another. First, we need to declare a class and initialize the button. When the button's clicked, I'll show you how to animate from one point to another. First, let's look at the class declaration. As shown, the animation sample class is derived from the form and the iAction event listener to receive the onActionPerformed button click event. I also have the button ID and the button object in the class. Here, we initialize the button that we're going to use to animate. First, we construct the button, setting the Start Animation text to it. Assign an action ID and add the current class as a listener using addActionEventListener. Finally, we add the button to the form using the addControl method. Here I'm going to show you how to start the animation once the button is clicked. First, we get the Control Animator object for the button using the getControlAnimator method. Then, we take the 2 points, start pause and end pause, as the start and end points for the animation. The point animation is constructed with the start and end positions and a linear interpolation, i.e., the animation will be linear. By calling and setting Set Auto Reverse Enabled to True, I've set the auto reverse property of the animation to true. This will have one forward animation and one backward animation playing in one iteration. Then I start the animation using the Start User Animation method. The parameter animation_target_position specifies the animation for the position properties. And with such simple steps, we can easily animate a button from one point to another. Now, let me introduce you to layouts in bada. A layout, in simple terms, is the organization of controls on a container. Many times, we wish that our controls are positioned at a particular area on our screen, such as the top left or bottom right. The layout management supported by bada helps us to achieve this easily without worrying too much about different sizes and resolutions, or the orientation of the device. Using layout management, developers need to arrange and take care of the layout in the proper way in order to configure the layout they want to adapt for multi-resolution support. A layout can be attached to a container, i.e., form or panel. Normally, the position of a child container is relative to the top left corner of the parent control. By applying a layout to the parent container, we can change the default top left behavior. We can specify layouts in either a single dimension, i.e. horizontal or vertical, or two-dimensional, i.e. a grid, and even in relative terms. We'll discuss these one by one here. Using the relative layout item causes each control's size and position to affect the size and position of the other controls added to the container. That is, the size and position of each child control is relative to the size and position of the other child controls of the container. When a relative layout is used, you must assign relationships between the controls. Using the relationship style of a child control, the layout can have the mentioned 4 styles. First, align my side to the side of another control, i.e., the 4 sides, left, right, top, and bottom, can be aligned relative to the sides of another control. Second, invalidate all the relationships on my side, i.e., there will be no relationships on any sides for the control. Third, align my position to the center of the container, i.e., align the vertical or horizontal position to the center of the container. Fourth, invalidate my center alignment. For example, invalidates the horizontal, vertical center alignment. Using the vertical box layout causes the controls to be aligned vertically, whereas using the horizontal box layout option causes the controls to be aligned horizontally within a parent container. The attributes that can be set for vertical and horizontal box layouts are: first, weight. This attribute specifies the extra space that a control occupies in the layout with respect to its size. The weight specifies how to utilize the empty space left after positioning a control. It's a floating point value and has a default weight of 0.0. Second, alignment. This attribute specifies how the controls are aligned horizontally or vertically. In the vertical box layout, the controls can be aligned horizontally to the left, center, or right of the parent. In the horizontal box layout, the controls can be aligned vertically to the top, center, or bottom of the parent. Third, spacing. This attribute specifies the spacing between the current and previously added control, vertical in the vertical box layout and horizontally in the horizontal box layout. The default spacing between the controls is 0. And fourth, margin. This attribute specifies the margin space that is left blank before applying the alignment attribute value. You can set the margin for the left and right sides in the vertical box layout, and for the top and bottom in the horizontal box layout. The default margin is 0. Using grid layout causes each control to be positioned in a cell of a two-dimensional grid. Each cell of the grid is sized based on the height and width of the control placed in it. The attributes that can be set for the grid layout are: first, stretch, shrink, or collapse. The attribute stretches, shrinks, or collapses a row or column if its size is less or more compared to the controls that have been added to it. Without this attribute, the size of the row or column typically follows the tallest or widest item in it. By default, these attributes are set to false. Second, alignment. This attribute specifies the side of the cell to which a control is aligned. You can align the control vertically or horizontally. The default alignment is to the left and top of the cell. Third, spacing. This attribute specifies the spacing between the current and previous row or column. The default spacing between the rows and columns of the grid is 0. And fourth, margin. This attribute specifies the margin space between the control and the sides of the cell. You can set the margin for all 4 sides of the cell. The default margin is 0. If the center alignment is used, the margin value is ignored. Let's take a look at an example now. Here I've tried to show the implementation of a relative layout. The first step is always to create a relative layout, and as I've shown here, I've created and constructed a new relative layout object. Next, we need to apply the layout to a container, and here I've used a 300 by 500 panel. Any other valid panel size can be used. Now, to use the relative layout features, we need an instance of the relative layout class. We can retrieve the instance from the container or use the same instance we created the container in the first place. To retrieve an instance of the layout applied to a container, use the getLayoutN method. The next step is to assign the relationships and specify the margin. The 3 labels used here are set with the fixed, scalable, and centered text. The creation part of these label controls is not shown here for the purpose of clarity. The setRelation method sets the relationships with respect to the other controls. For example, rect underscore edge underscore relation underscore left underscore to underscore left says that the left edge of the source control is aligned with the left edge of the target control. The setMargin method specifies the margin gap to be left at the left, right, top, and bottom for the control. For example, the first use of setMargin text left top 15 0 15 0 leaves a margin of 15 to the left and top of the control. Up until now, I've explained how to create a UI by writing the source code. Now, let's learn how to use the UI Builder to design a user interface. The UI Builder is a design environment for creating user interfaces for applications. The UI Builder stores the created forms as XML files in the project folder in the IDE. You can create a form, add controls to the form, and set the properties of the controls by using the UI Builder. Developing a user interface in the XML format using the UI Builder offers many advantages. First, localization becomes easier. If you create localized XML files for each locale, the files are automatically loaded according to the locale, and you don't need to modify the source code for the UI depending on the locale. Another important advantage is that you don't need to support various types of devices. If you create XML files for each device that has different resolutions, the appropriate XML file is loaded for the device. And finally, you can design more beautiful and sophisticated UIs through this "what you see is what you get" interface. Let's talk about some of the common properties that can be set when using the UI Builder. The first one is the object ID. This ID is an important property for accessing the control from within the source code. You can define the size and position of the control on a form, as well as the text, text alignment, and text color. In addition, you can define the parent-child relationship. When the XML format UI file is loaded, memory is allocated to each of the controls in the XML file, and the hierarchy of the controls is set. In addition, the properties specified in the XML file are set to the corresponding controls. To use these controls in the source code, you can get the pointer to the control using its ID, and, if necessary, you can set additional properties. For example, you can set the event listener or action ID and set the items for a list in the source code. The UI Builder can also be used to generate code automatically. The code can be event listeners. The steps that need to be followed are shown here. First, open the UI Builder. Right-click on the form and select Add Event Handler, as shown here in Figure 1. Then you can select the desired listeners, and shown here in Image 2 is the Orientation Event Listener. Once you select Finish here, the relevant code will be added automatically as shown in Figure 3. Now, let's look at how you can load and use an XML UI file. As you can see, to load and connect an XML file to a form, the UI name must be specified in the construct function of the form. To acquire the handle of a control from the loaded form, you can call the getControl method with the ID specified in the UI Builder. You can use string resources in your application to handle and display localized strings. The IDE generates language-specific XML files with the language and country code, such as the eng-gb.xml file from the string tables to the res folder of the application project. The OSP app resource class of the app namespace handles localized string resources based on the preferred display language that's defined in the device settings. Depending on the device language setting, the proper string is picked up from the string table. The application can then use the app resource getBitmapN method to obtain the bitmap image which matches the screen density. If the matching image doesn't exist, the image of the baseline density folder, screen density high, is used. When the auto option scaling is enabled, you can load target device-specific resources, or a best matching resource if the target device-specific resource is unavailable. Application resources are placed under the /res folder, and the directory structure within /res determines how the bada platform implements the resource fallback mechanism to find the appropriate resource. When the application requests a resource, the resource fallback mechanism first tries to find the exact resource for the current device resolution. If a device resolution specific resource is not found and the auto-scaling option is enabled, the bada platform widens its search to the other device resolutions to find a best matching resource. In this lecture, we learned about using some of the complex UI controls. Let's summarize. We have a gallery class that can be used to display a set of still images one at a time. You can also display the images as a slideshow. The search bar control can be used to enter search keywords and display the search results. We also learned about multi-touch support. Then we discussed using multiple forms. Finally, we learned how to use the UI Builder to design UIs and using the app resource for strings and loading bitmaps.